Welcome. You found your way to a quiet place, a corner of the night where we move more slowly and let the noise of the surface world fade. This channel is a shared vessel for calm journeys into the deep ocean, into hidden layers of our planet that most of us will never see, but can still imagine. Stories shaped by depth, pressure, time, and long stretches of silence. And if you'd like to return to this place again, a quiet like or subscription helps keep these slow journeys afloat. For now, make yourself comfortable, and let's begin our descent. Somewhere far beyond the shoreline in your mind, out in the wide Pacific night, the water does not simply get deep. It keeps going and going until it becomes almost impossible to hold in your imagination. There is a place where the weight of the ocean above presses with a pressure beyond anything we feel on land. A place so remote that only a handful of humans have ever passed through the darkness nearby. Tonight, follow me as we drift toward that place in thought alone. You do not need charts or numbers. You do not need to know how submersibles are built or how maps of the seafloor are drawn. You can simply listen and let the images form and fade as they wish. Somewhere in the Pacific, there is a trench so deep, its floor is always shifting, always remaking itself, a moving target at the very bottom of the world. And there are good reasons to wonder whether we will ever truly touch its final changing bed. Deeper than imagination, stating the Pacific's impossible promise. So, make yourself comfortable again, and slow your thoughts just a little more, because now we're going to follow that moving target all the way into the darkest folds of the Pacific. When people say, the bottom of the ocean, they often mean one very specific set of places, the Hadal Trenches, those narrow scars in the seafloor where the Earth's crust bends and dives back into the planet. We often picture a single pit, a neat hole at the edge of a map, but in reality there are many. The Kural-Kamchatka Trench, the Tonga and Kermadec Trenches, and, most famous of all, the Mariana Trench, whose Challenger Deep is usually named as the deepest point on Earth. Imagine a cold, elongated valley nearly 11 kilometers beneath the surface, a place so far down that Mount Everest could stand inside it and still be drowned in water. That is the destination we claim we want to reach. But what does it mean to reach such a place? To stand there, to stay there, to understand it in the way we understand a mountain or a glacier on land? The core claim of this journey is a quiet one. There are physical limits, geological restlessness, and even conceptual problems that may keep us from ever fully, continuously, or meaningfully touching that deepest Pacific floor in the way our stories suggest. Because when we look at our own history, the contrast is startling. We've walked on the moon. We live for months aboard space stations. We have wrapped our planet in a web of satellites that never sleep. Yet only a tiny handful of fragile submersibles have dipped, briefly, into small patches of the Hadal seafloor. A few hours here, a landing there, a narrow cone of light on a world-sized darkness, and then the long, careful climb back toward the surface. Down there, the water above you weighs as much as a stack of airliners pressing on every square meter of hull, more than 1,000 times the pressure you feel right now. To survive, a vessel must be shaped like a perfect sphere, thick and heavy, its windows reduced to tiny circles, its doors more like sealed plugs than anything we would recognize. Now, picture what happens when a single seal fails, or a hairline crack grows. There is no gentle warning, only instant, crushing loss. So the deep Pacific remains an almost alien world, a hidden landscape of mud and rock and slow-falling snow of organic dust, seen only where our lamps carve out a moving tunnel of pale light. Even when we do touch the sediment with metal feet, the ground itself may be sliding, slumping, remade by earthquakes and landslides faster than we can map it. The deepest point is not a fixed address. It creeps and flickers along the trench like a shadow. And this is where the mystery softens into something stranger. Perhaps the obstacle is not just danger, or money, or politics, but the way the bottom itself refuses to stay still, refuses to be one simple place we can conquer and then be done with. If the Pacific's floor is always folding, always sinking, always rearranging its cold geometry, then what exactly are we trying to reach? And how do you arrive at something that is always, quietly, moving away? Where are you listening from? Connecting your world to the abyss. So before we chase that moving floor any farther, let's pause together for a moment and come back to where you are. The Pacific might be folding and sinking in the dark, but right now you are in a very different world, here at the gentle, familiar surface of the Earth. Make yourself comfortable if you haven't already. Notice the place around you, the temperature of the room, maybe a soft blanket against your skin, the way your bed or chair gives a little under your weight instead of pushing back with crushing pressure. Perhaps there is a quiet hum nearby, a fan, a distant car, the faint electronics glow of a screen. Up here, the air is light, the sounds are soft, and nothing is trying very hard to squeeze you. If you like, slow your thoughts just enough to notice the small details. Are you close to a coast where the smell of salt sometimes drifts in on windy days? Or are you far inland, where the ocean is more an idea than a daily presence? Have you ever stood beside the sea at night and watched the surface turn black and reflective, a moving mirror that hides everything beneath it? Or maybe the nearest water is only a lake or a river, a quieter edge where the world seems to end. Imagine, just for a second, that the surface of the Pacific is not thousands of kilometers away on a map, but only a few meters from where you are now. A dark sheet of water just beyond your wall, or just below the floor. It feels almost reachable, doesn't it? Now picture what happens when we stretch that distance downward, not by meters, but by kilometers, until there are nearly 11 of them above the deepest trenches, layer upon layer of cold, heavy water pressing down. Right where you sit, the air presses on you too, but so gently that we forget it is there. One atmosphere, comfortable, ordinary. At the very bottom of the Pacific, that pressure becomes more than 1,000 times greater, the weight of an entire column of water bearing down on every square centimeter. Enough to crumple most metals if they are not shaped with exquisite care. The water there hovers just above freezing, a near-black, near-frozen world that has never seen direct sunlight, even though it lies just beneath the same sky you know. We often picture exploration as loud and heroic, but here, in this small, hidden corner of the internet, we're going to do something quieter. If you feel your attention drifting, that's all right. You can let it wander in gentle circles. You can half listen, half dream. The story will keep sinking, slowly, layer by layer, whether you follow every word or only catch fragments. If you'd like this calm descent to exist in your feed again, liking, subscribing, or simply staying with us until the end helps more than it seems. It tells the algorithms that there is room for slow journeys into unreachable places. And as you rest where you are, warm and safe at the surface, we'll begin to leave that comfort behind and follow the water downward into the deep Pacific, where our bodies, and maybe even our best machines, were never meant to go. Letting go and sinking slowly, transitioning into journey mode. So before we follow that water, make yourself comfortable again, right where you are, as if your bed or your chair were the deck of a very quiet ship, barely moving on a calm, dark sea. Let your jaw loosen just a little, so your teeth are not quite touching, and feel how that tiny change sends a soft signal through your whole body that the work of the day is over. Let your shoulders sink, heavy and warm, into whatever is holding you up, and notice the way your back lengthens when you stop asking it to stand tall. If you can, adjust your pillow or the way your head rests so that your neck feels supported and your eyes don't need to do anything at all. As you settle, slow your thoughts until they move at the pace of a drifting current, not rushing anywhere, just carrying small leaves of memory and half-formed plans along the surface of your mind. Now, follow me, not with your muscles, but with that quieter part of your attention. We're going to leave this room without standing up. Imagine the walls around you becoming transparent, the ceiling thinning into night, your familiar things growing small beneath you, as if you were gently rising. Even though your body doesn't move, your home shrinks to a faint, warm square of light on the dark skin of the earth. From there, we begin to travel outward, across the land, unhurried and silent. City lights blur into soft constellations below us. Roads become pale threads, and then even those threads fade as we pass over mountains, forests, and wide sleeping fields. We often picture maps as flat and simple, but from up here the world feels round and alive. A turning sphere of cloud and ocean and cold, clear air. Soon the coastline appears, a wavering edge where the solid surface falls away into water. We slip over it without a sound, leaving the last beads of human light behind, and move far into the open Pacific, under a dark, starlit sky. Below us there is only blackness and the faint suggestion of waves, but beneath that blackness lies a deep, hidden architecture of trenches and scars, places carved slowly over tens of millions of years, while our visits last only hours. Now, picture what happens at those edges of the Pacific Plate, where pieces of the Earth's crust bend and plunge downward, dragging seafloor into the planet's interior. That sinking over unimaginable spans of years has gouged out the great trenches we are heading toward, places where the pressure of the water above would crush almost anything not shaped and strengthened with exquisite care. Compared to that patient, geological time, a human expedition is a brief exhalation. In many ways, this deep Pacific is one of our last true frontiers, more unexplored in detail than the dusty plains of Mars or the bright cratered surface of the Moon. We send orbiters to other worlds and map them from pole to pole, yet here, on our own planet, there are valleys and slopes no camera has ever seen clearly, no instrument has traced in fine relief. Not because we forgot about them, but because they are wrapped in darkness, distance, and crushing weight. So as you rest, imagine yourself inside a small research vessel. Lights dimmed, instruments humming softly around you. The surface is a fading memory above, a thin, bright film we have already left behind. Outside the hull, the last blue of the upper ocean is dissolving into ink, and we begin to sink, very slowly, as if the whole world were exhaling and letting us fall. In the next part of our journey, we'll follow that descent, layer by layer, and see how the ocean itself begins to push back against our attempt to reach its deepest floor. The ocean you think you know versus the world you never see. As we sink away from that thin, bright film of memory above, we carry with us an image we hardly ever question. We often picture the ocean as a single simple thing, a vast blue sheet wrapped gently around the earth, with sunny beaches at the edges, rolling waves at the surface, and somewhere far below, a flat, sandy floor where everything finally comes to rest. Make yourself comfortable with that picture for a moment. Warm light on the water, playful dolphins cutting through the waves, a few scattered reefs, and then, in your mind, the bottom. Like the floor of a swimming pool stretched out to the horizon. It feels calm, knowable, almost domestic, as if the sea were just a deeper version of the same shallow place where we stand with our feet in the surf. Now picture what happens as we keep descending. That simple idea of the bottom begins to fracture. Beneath the surface there is not one ocean, but a layered, structured world. Broad continental shelves that extend like submerged terraces from the coasts, steep continental slopes that fall away like underwater cliffs, wide abyssal plains that seem to go on for thousands of kilometers. And then, suddenly, a sharp break where the seafloor plunges into narrow, elongated trenches. These trenches are not gentle bowls. They are more like slits cut into the crust of the earth, places where one tectonic plate is forced beneath another, and the geometry becomes strange and severe. We're going to leave behind the idea of a single deepest point, and instead follow a chain of chasms, each with its own hidden architecture, each reshaped over years and centuries by forces we rarely feel at the surface. Oceanographers give a name to the deepest of these realms, the Hadal Zone, the cold band of water and rock beneath about 6,000 meters. Imagine it not as one giant pit, but as a scattered archipelago of trenches and troughs, a world within the world, more like a series of underwater canyons than a single final floor. In the Pacific alone, these Hadal places form a broken necklace of depth, each segment slightly different, each one difficult to even map, let alone truly touch. Inside those canyons, the bottom is anything but flat. There are overhanging walls where rock has been torn and folded, sediment-choked valleys where fine particles drift down like slow undersea snow, abrupt fault scarps that step the seafloor up and down, and low ridges where the crust has buckled. If you could walk there, you would not be strolling across a smooth plain. You would be picking your way through a maze of slopes and ledges and sudden drops. And above all of this hangs the ocean itself, not as a passive weight, but as a moving, crushing barrier. The water column is alive with shifting currents that scour and pile sediment, with tiny, constant micro-earthquakes along the subducting plates, with slow landslides that send clouds of mud rushing through the trenches and quietly redraw the map of what we call the deepest point. It is not just that we have not reached a final bottom. The bottom itself refuses to stay still. Follow me a little further, and we'll see how in these depths, that restless water and shifting rock turn from scenery into opposition, as pressure, darkness, and motion work together to push back against every attempt we make to go all the way down. Why just go deeper doesn't work, stating the core problem. So when we say the water and rock are turning into opposition, we're not just being poetic, we're drawing a line between two very different ideas. One is, we haven't gone there yet. The other is, we may never be able to go there in the way we imagine, with sturdy ships drifting over a mapped floor, returning whenever we like. That second vision sounds simple, almost inevitable. It is not. We often picture the bottom of the Pacific as a place we could eventually tame with better steel, stronger glass, more money, more time. Make yourself comfortable for a moment and imagine that familiar story of progress. First we dive a little, then a little more, until at last we roam freely along the deepest trench, as casually as we walk across a parking lot. Now, picture what happens instead when we send our best machines down to nearly 11,000 meters. Down there, the pressure is more than 1,000 times what you feel at the surface, as if the weight of a small mountain were pressing on every square meter of hull. Metals that seem solid in our hands begin to flow, ever so slightly. Under that load, seals that keep out water on the continental shelf are squeezed, twisted, and slowly unmade. Electronics that hum comfortably in the open air are chilled into silence by the cold, dark water. The environment does not just wait for us, it pushes back. Our instruments arrive, and then the deep begins to erase them. Delicate landers settle onto soft sediment, only to be swallowed grain by grain as mud creeps up around their legs over months and years, burying sensors that were meant to watch the world beneath. Cables are abraded by tiny movements. Housings are stressed by subtle shifts, and when a slope fails in a submarine landslide, the entire landscape can slump, dragging our equipment away or entombing it beyond recovery. The target we so carefully aimed at has moved. Even our most advanced submersibles are not rugged explorers in the way we like to imagine. They are fragile, highly specialized compromises, shaped into thick spheres and compact frames, because anything broader or more flexible would be crushed. They can descend, pause, take a few careful samples, trace a short path along the trench wall or floor, and then they must rise. They are not trucks driving across a continent. They are more like needles, dipping briefly into a vast, unseen body. Follow me a little further in thought. Each mission is a one-off negotiation with the deep, tuned to a narrow set of conditions, always at the edge of what our materials and our nerves can bear. So, when we talk about reaching the bottom, we are already simplifying, already pretending that there is a single, stable thing to reach. But what is this bottom in a basin where sediments drift, plates dive, and trenches flex and change shape? To understand why it resists us so completely, we first have to ask whether the bottom of the Pacific is even a fixed place at all, and what it becomes when the Earth decides to move. To understand the bottom, we must redefine the ocean itself. So to understand why we can't truly reach the bottom, we first have to slow our thoughts and ask a quieter question. What is this ocean we're trying to touch, really? We often picture it as a single calm bowl of water resting above a flat waiting floor, as if somewhere there is a final step down, a last still point we could one day stand on and claim. But follow me for a moment, and make yourself comfortable with a different image. The Pacific is not a pool laid gently on top of stone. It is a thin, cold skin of water draped over a living, shifting shell of earth. Beneath the surface, far below the waves and the light, the seafloor itself is broken into vast plates, slabs of rock that creep past one another by centimeters a year, yet over millions of years redraw the map of the deep world entirely. Now, picture what happens where those plates meet. Along the edges of the Pacific, one plate bends and dives under another, pulled slowly back into the planet. That downward fold is what we call a trench, a long, narrow wound in the crust where the seafloor tilts and sinks, where one part of Earth slides beneath another and disappears into heat and pressure. The famous Mariana Trench, the Tonga Trench, the Kermadec Trench. Each is a place where the bottom is literally folding back into the planet. We often picture the seabed there as silent and unmoving, a kind of eternal dark plain. It is not. Even in those frozen-feeling depths, the rock shudders with constant micro-earthquakes, tiny slips we almost never feel at the surface, but which ripple through the sediment. Fine particles of mud and shattered shell creep down slope in slow avalanches. Sometimes, whole walls of sediment slump and slide, filling one hollow while carving another a little deeper. So the bottom is not a single dot we can mark on a map, but a restless landscape that wrinkles and relaxes, that sags, fractures, and heals. The deepest known point in the Pacific has shifted as we've improved our measurements, but it also shifts because the Earth itself is moving under our feet, or under our hulls. A trench floor can sink a little more as one plate continues to dive. A nearby slope can collapse and briefly make a new, slightly deeper crease. When we say we want to reach the bottom, which moment are we talking about? The shape of today, or the shape of 10 years from now, after another series of subtle quakes and silent landslides? In a world where the target itself is drifting and deforming, true, stable access becomes something more elusive than just solving for pressure and engineering. In the next part, we're going to see how those crushing physical limits meet this moving, changing seafloor, and why, together, they keep the Pacific's deepest places just out of our permanent reach. Falling through blue, a slow, visual descent into the Hadal Zone. So to feel what those limits really mean, follow me, and we're going to turn all those numbers into a slow, sinking journey. Make yourself comfortable for a moment, and imagine that instead of standing on the deck of a ship, you are gently lowering yourself through a hatch in the Pacific, beginning a fall that will last for hours. At first, it feels almost ordinary. Above you, the surface is a restless, silver ceiling, still tied to wind and weather and sky. Sunlight pours down in bright shafts, fish scales flash like tiny mirrors, and the water is still a familiar, welcoming blue. We often picture the ocean as a single, uniform thing, just down. But here, in the first few dozen meters, you are still very much in the same world as the air and clouds. Now, picture what happens as we keep sinking. The blue begins to thicken, as if someone were slowly turning down a dimmer switch on the entire Earth. Reds vanish first, then oranges, then yellows, until even your own hands look drained of warmth, reduced to pale shapes moving in a cool green-blue haze. Every 10 meters, the pressure adds another atmosphere, another invisible weight of air stacked on top of you, until after just a few hundred meters, your body would be crushed without the careful shell of a submersible. Time stretches. The last clear rays of the sun fade above us, and we slip into the twilight zone, that long, melancholy band where day is never quite gone but never truly here. The water feels different now, not to the touch, but in its mood. It becomes a slow, heavy blanket, layer upon layer of cold weight resting on your shoulders. Not malicious, not kind, simply obeying gravity and the patient rules of physics that have held for billions of years. Deeper still, and the blue gives way to something else. Darkness is no longer an absence, it is a substance, a quiet, almost velvet medium that closes around the sub. We pass through the midnight zone, where no sunlight from the surface can ever reach, where the only flickers come from the brief, ghostly pulses of bioluminescent life. Above you now is not a roof of ice, not a glacier, but a column of water so tall that if we placed Mount Everest here, upside down, its summit would still be more than a kilometer above your head. And we are not done. We keep falling, past the imaginary peak of that drowned mountain, into the Hadal Zone, the last narrow slice of depth, carved into trenches like the Mariana. Here, pressures climb toward 1,000 atmospheres and more, every square meter of hull carrying the weight of dozens of jumbo jets. Only a few fragile creatures and a handful of human machines have ever existed in this cold, shifting place. In the next part, we're going to leave our slow descent and look closely at those machines themselves, and why, even at their strongest, they may never truly belong here, when water weighs like rock, feeling the pressure of the deep. So let's stay here for a moment, suspended in that dark column of water, and make yourself comfortable in the thought that what we're really feeling now is weight. Not the weight of rock or ice, but the weight of the ocean itself, pressing down on us from the surface all the way to this hidden place beneath the waves. At sea level, where we live our ordinary days, we already carry a quiet burden. Every square meter of your skin, of your house, of the ground around you, sits under one atmosphere of pressure, the weight of the whole sky resting gently, invisibly on the earth. We don't notice it because the air inside our bodies and our buildings pushes back, matching that pressure so perfectly that it cancels itself out. Now, picture what happens as we sink. With every 10 meters or so, the pressure climbs by about one more atmosphere, another layer of weight added to the stack. By the time we reach the Challenger Deep, more than 10 kilometers down, we're not at 2 or 3 atmospheres, like in a swimming pool or a shallow bay, but at over 1,000. We often picture numbers like that as abstract, but here, each square meter of hull carries the weight of dozens of jumbo jets, a slow, relentless squeeze from the entire ocean above. Follow me into a simple image. Take a soda can in your hand and give it the lightest squeeze. It crumples suddenly, not because your fingers are especially strong, but because the thin metal can't resist a small imbalance in pressure. Now replace your fingers with an entire column of cold Pacific water, kilometers deep, perfectly even, pushing not just from one side, but from every direction at once. That's what a submersible hull has to endure. Pressure down here is not a single heavy hand pressing from above, it is a three-dimensional embrace, trying to erase any empty space. Any hollow volume, a cabin, a battery housing, a tiny connector, is an invitation. If the walls are not exactly the right shape, if there is the smallest flaw, the ocean will find it, and the material will behave, in the end, like that fragile can. Not because it is weak, but because the imbalance is so absolute. We're going to carry that thought into the details. How do you build a door that can move when the sea is trying to weld it shut? How do you make a window that lets in light, but not 1,000 atmospheres of pressure? How do you ask a tiny sensor to open, close, and whisper its data back to the surface, when the deep Pacific is quietly, patiently trying to close it forever. In the next part, we'll see how engineers try to answer those questions, and what happens when the ocean answers back. Shells of steel and spheres of air, how deep submersibles survive. So when engineers finally try to answer back, they do it with shapes that look almost strangely simple. We often picture sleek submarines with long hulls and sweeping fins, gliding like metal whales through the deep. But at the very bottom of the Pacific, under more than 1,000 atmospheres of pressure, the safest thing you can be is not a whale at all, but almost a bead. Follow me for a moment and make yourself comfortable in that thought. The basic strategy for going Hadal is to hide our fragile, air-filled world inside a nearly perfect sphere, carved from titanium or specialized steel, polished and inspected until every curve is smooth, every contour continuous. Now, picture what happens if you try to take a box, or a cylinder, or a flat window down into that cold, crushing place. The pressure finds the corners, it finds the flat spots, it finds every edge, and it pushes until they bend, then buckle, then fail. A sphere, by contrast, has nowhere for the force to gather. The weight of the ocean presses equally from every side, flowing along the metal like wind over a rounded stone, so that no single point has to bear more than its share. That is why the deepest crude dives in the Pacific rely on small, heavy, spherical chambers for people. With everything else, batteries, flotation, cameras, strapped on outside like a kind of life support reef clinging to a tiny steel planet. It is not elegant in the way we usually imagine exploration, but it works. There is a cost, though, and it grows with every extra meter of depth. To survive greater pressure, the sphere's walls must become thicker, and as they thicken, they become heavier. And as they become heavier, they need more flotation just to hover above the seafloor. Inside, the space where a human can actually sit shrinks, until you are left with a cramped bubble barely big enough for 2 bent knees and a few essential instruments. How much science can you really do when you can hardly turn your head? And then there is the quiet terror of imperfection. At the surface of the Earth, a tiny weld floor is an annoyance. Beneath 11 kilometers of Pacific water, that same floor can be the beginning of a crack that races through steel in milliseconds. Microscopic scratches, invisible inclusions in the metal, a slightly misaligned bolt, each must be hunted, measured, and, if possible, removed. Construction becomes a kind of ritual of doubt. Repeated tests and scans, years of careful work for a vessel that may only make a handful of dives. Here's the pattern interrupt. Even when we succeed, what we reach is not the bottom in the way we say it. These spherical shells of steel and air can touch down briefly and carefully on a patch of sediment smaller than a city block, in a trench that stretches for hundreds of kilometers. We're going to talk about reaching the bottom, but what we actually achieve are tiny footprints in a vast, shifting landscape, glimpses rather than journeys, visits rather than residents. In the next part, we'll see why, even if our shells were perfect, the deep Pacific itself keeps moving the finish line away from us. The ocean that bends metal, why materials hit a hard ceiling, and even inside those tiny footprints, the deep Pacific begins to show us another kind of boundary, one that doesn't look like a cliff on a map, but feels more like a wall in the properties of matter itself. As we slow our thoughts and look closely, we find that the ocean beneath us is not just a cold, dark place, but a patient machine for bending, warping, and finally defeating almost everything we can build. We often picture high-tech submersibles as invincible, wrapped in silver titanium or exotic alloys, gliding calmly through the deep. But at 11,000 meters, the pressure is more than 1,000 times what you feel at the surface, like a stack of jumbo jets pressing on every square meter of hull. To stand against that, even metals like titanium and miraging steel, even advanced composites, have to become thick, curved, and carefully shaped, or they simply give way. Now, picture what happens when we try to make that shell stronger. We add thickness, we add reinforcing ribs, we choose denser, tougher materials. The hull becomes heavier, the whole vehicle sinks more eagerly, and so we must add more buoyancy just to keep it from plunging uncontrollably into the trench. That buoyancy usually comes from big blocks of special foam or hollow glass spheres, which then need their own structure, their own protection to the hull. So strength leads to weight leads to bulk, and bulk leads to complexity. Each new layer of safety adds cables, joints, seals, and supports, all of which have to survive that same crushing pressure without leaking or cracking. In theory, we're going to build a perfectly safe vessel. In practice, every improvement comes with a penalty, and the returns get smaller with each step down into the Hadal world. Because somewhere along that spiral, the easiest thing to shrink is not the machinery, but the humans. The pressure hull that actually keeps a crew alive contracts to a tiny sphere, maybe 2 meters across, then smaller, until it feels less like a room and more like a metal seed drifting through the cold. We can fit fewer windows, fewer manipulators, fewer instruments. At some depth, we have to ask, if the craft becomes so cramped and so limited that you can barely move, barely see, and barely touch the seafloor, is it still worth sending people at all? Even when we leave humans out of the equation, the ocean keeps asserting itself. Uncrewed housings for cameras, batteries, and sensors are squeezed just enough that their shapes change, their seals creep, their electronics drift out of alignment. A circuit board flexes by a fraction of a millimeter, and a clock runs slightly fast. A battery casing bows inward, and a connector loosens, and an instrument that worked perfectly at the surface fails silently in the dark. So the limit might not be a single dramatic number we can print in a record book, but a quiet zone of trade-offs, a region where cost rises, risk deepens, and the actual capability of our vehicles shrinks until further progress feels almost meaningless. In the next part, we'll follow this idea a little further and see how the deep Pacific turns that invisible boundary into a moving target that may never quite let us catch up. A place that moves beneath our feet, the restless Pacific trenches. So let's stay with that idea of an invisible boundary for a moment, and make yourself comfortable as we let it sink in that the line we draw for deepest is not painted on stone, but on something that moves. We often picture the bottom of the Pacific as a single smooth floor, a quiet level plain far beneath the waves, waiting patiently for us to arrive. But follow me, because the real landscape is nothing like that. The deepest Pacific trenches are not scars that have healed and gone still. They are open wounds in the crust of the earth. Places where one giant plate of rock bends and dives beneath another in what geologists call a subduction zone. Imagine the Pacific plate, heavy and dark, sliding down and under its neighbors, dragging the seafloor with it, folding it into long, curving trenches like the Mariana, the Tonga, and the Kermadec, each one a cold crease where the surface of our world turns downward and disappears into the interior. Now, picture what happens along the walls of those creases. Sediments, tiny grains of rock, shells and dust that have been drifting down for years, do not just settle gently into place. Under the immense pressure of the water above, and the slow shaking of the plates beneath, they can suddenly let go, collapsing in underwater landslides that race down the trench slopes. Some pockets are buried and lifted, filled in by these avalanches, while other pockets are pulled even deeper as the plate continues its slow dive, like a conveyor belt carrying the seafloor into the dark. If we could switch on the lights down there, we would not see a broad, obvious basin with a neat, lowest point. Instead, we would see microtopography, small ridges, mounds, and tiny depressions, some only a few meters high or deep, sculpted by landslides, chemical reactions, and the constant bending of the crust. The true deepest spot is often not a grand valley, but a narrow crease, a hidden fold in the fabric of the trench, hard to find, easy to miss, and always being reshaped. Because of this, our maps keep changing. When the Five Deeps expedition revisited places like Challenger Deep with modern instruments, they found that older charts were off by tens of meters, sometimes putting the supposed deepest point in the wrong little wrinkle of the seafloor. It is not that anyone measured badly, it is that we are trying to pin a precise number onto a moving, rumpling surface. So even if we touch the deepest known point today, the real lowest place on Earth's ocean floor may already have slipped somewhere else along the trench, changing faster than we can map it, faster than we can build a craft, sail it out, and sink it down. And this restless seafloor does something even stranger to our attempts to explore it, as we'll see when we look not just at where the bottom is, but at how the deep Pacific quietly erases our tracks. Touching a point versus knowing a world, what reaching really means. So when we say the seafloor keeps slipping away from us, we're also saying that our idea of reaching it starts to dissolve a little, like salt in cold water. We often picture a single triumphant moment, a tiny submersible settling onto the very deepest point, a robotic arm planting a flag or a plaque, and a voice crackling over the radio to announce that, at last, we have touched the bottom of the Pacific Ocean. Now, picture what happens instead. The craft arrives after hours of descent through a dark, crushing column of water, its hull holding back pressures that would flatten almost anything we build on the surface, and for a few quiet minutes, it rests on a patch of soft sediment, in a place that might not even be the true deepest spot by the time we get there. Then, almost as soon as it has settled, the clock starts to shout at us in silence. Batteries drain, life support margins shrink, tiny temperature changes creep into electronics that were tested for years, but never quite for this exact moment. The pilot, or the control team far above, knows that every extra minute on the bottom is another minute of risk on the way back up. So the sub cannot linger the way we might linger on a beach or a glacier. It has to rise. In that short window, under that immense pressure, a few cameras can turn, a few fragile sensors can taste the water, a few sampling tools can bite gently into the sediment before their hinges and seals begin to complain. A manipulator arm that works beautifully in a laboratory may move stiffly here, or not at all. A delicate chemical sensor might fail after a single dive. Sometimes the most we bring back is a handful of mud, a few minutes of video, and a long list of questions. So we have to slow your thoughts for a moment and ask, does touching one coordinate on the map mean we know this world beneath the waves? A single touchdown does not reveal the ridges and canyons that extend for hundreds of kilometers, the slow landslides that bury old scars, the chemistry that shifts with each trickle of deep current, or the ecosystems that may bloom and fade over years we never see. Here's the pattern interrupt. When we say reach the bottom, we usually mean what a mountaineer means by reach the summit. But the Haddle Zone is not a peak to stand on. It is an enormous, shifting, three-dimensional place. To truly reach it would be to go there often, stay there long, move around freely, and study it in patient detail, the way we map coastlines or walk through forests. That would mean submersibles that can shrug off this pressure for months, not hours, habitats that can sit on the sediment like small research stations on another planet, and networks of instruments that watch the trench change. Quietly, year after year, we're going to need not just one brave dive, but a stable, enduring presence in this hidden world. So make yourself comfortable with a different story. Imagine that reaching the bottom is not a single heroic plunge, quickly erased by moving mud and drifting sand, but a long, continuous conversation with the deep Pacific, one that never really ends. When we define it that way, the distance between where we are and where we dream of going becomes much clearer, and, as we'll see next, the obstacles grow even more profound. A quiet roll call of the few who have gone. And yet, before we talk about why that conversation with the deep Pacific is so hard to sustain, we should quietly remember the few times we have managed to whisper a single word into it. Make yourself comfortable for a moment and slow your thoughts, because this roll call is very short, and each name carries an almost fragile weight. We often picture exploration as a busy highway of ships and stations, but here, it's more like a narrow path traced only a handful of times in all the years we've had the technology. Follow me back to 1960, to a cold January in the Western Pacific, when a strange, balloon-like vessel called the Trieste drifted above the Mariana Trench. Beneath its float of gasoline sat a thick steel sphere, barely large enough for two people, designed to hold back a pressure more than 1,000 times what we feel at the surface. Inside that metal bubble, Jacques Piccard and Don Walsh descended for hours through a darkening world, watching light fade, feeling the gentle sway of a craft that could not move quickly or freely, only sink and rise. Now, picture what happens when they finally neared the bottom. Not a clear view of some sharp, rocky abyss, but a cloud of fine sediment billowing up under their tiny lights, turning the deepest known place on Earth into a pale, swirling fog. They touched the seafloor for only a short time, saw very little, and then began the long, cautious journey back. More than 50 years passed before another human went there alone. In 2012, filmmaker and explorer James Cameron rode a very different machine, the Deep-Sea Challenger, a slender vertical submersible that fell through the water column like a slow, controlled elevator. Its pilot sphere was again a small, hardened capsule, a kind of personal iceberg of steel, hidden inside a taller green tower of flotation. He too reached the deep, stayed briefly, peered through a narrow window at a tiny patch of mud, and then rose away from that silent place. Since then, a few private and scientific expeditions have repeated journeys into the Hadal Zone, into the trenches of the Pacific, and beyond, logging dives that we can still count on our fingers. Compared to the thousands of crewed trips into low Earth orbit, to the steady traffic of capsules and space stations circling far above our atmosphere, these ventures beneath the ocean feel almost like rare eclipses. Space, for all its emptiness, has become a busier neighborhood than the deepest water on our own planet. Each of these dives is less a routine mission and more a delicate exception, a brief touch of a distant star rather than the building of a base on its surface. They show us that visiting the bottom is possible in principle, but also that our presence there is fleeting and precarious. In the next part, we're going to see why turning that rare touch into something lasting runs up against the hard physics of pressure, materials, and a restless seafloor that does not want to sit still beneath us. Listening from above, how we sense the deep without being there. So, if our rare visits to the bottom are brief and fragile, what do we do the rest of the time? We listen from above. We trade the feeling of boots on a seabed for the quiet patience of echoes and tiny ripples on the ocean's surface. Make yourself comfortable for a moment and imagine a research ship drifting over a deep Pacific trench on a still, dark night. The water looks calm, almost indifferent, but beneath that flat surface the seafloor drops away for kilometers, a cold, hidden world we will almost never touch directly. Instead, we send sound down and wait for it to come back. This is where multi-beam sonar becomes our paintbrush. We're going to sweep the ship slowly along a path, and from its hull a fan of sound pulses spreads out, like a hand opening over the deep. Each pulse travels downward, feels the seafloor, and returns as a faint echo, delayed by just enough time to tell us how far it has gone. By measuring thousands of these echoes, from many angles we build a picture of depth and shape, a kind of shadowy relief map drawn entirely from sound. We often picture maps as something crisp and certain, with sharp lines and neat labels. But here, the lines are soft. The deeper the water, the wider the beam spreads, and the less precisely we know what any single echo really bounced from. A single measurement might represent a patch of seafloor larger than a city. For all our technology, all our ambition, and all our restless desire to explore, we are still tracing the outline of a vast sculpture we can only feel with gloved hands. Now, picture what happens when we step even farther back, all the way into orbit. Satellites cannot see the sea floor through kilometers of water, but they can sense something subtler: gravity itself. Where there is an underwater mountain, gravity pulls a little more strongly, and the sea surface bulges up by a few centimeters. Where there is a trench, the water dips ever so slightly. By measuring these tiny rises and falls in sea surface height over many years, we infer the presence of ridges, plateaus, and deep cuts in the ocean floor. It feels almost like cheating, reading the shape of the Earth beneath the ocean by watching how the water clings to it. Yet this vision, too, is coarse. In some regions, our gravity-based maps of the Pacific are less detailed than our maps of Mars or the Moon. Subtle signals, small bulges or dips in the seafloor, hint at deeper structures and shifting depths that no submersible has ever confirmed. They whisper that the deepest point might not only be changing with time, but might already be somewhere we have not even outlined clearly. So we listen, and we sketch, and we slow your thoughts with these distant measurements. But we do not truly walk that landscape. We cannot run our hands over its rocks or watch its creatures move through the black water in their own time. For now, the bottom of the Pacific remains a place we know mostly as an absence in our data, a negative space in our models. And the more carefully we listen from afar, the more we begin to suspect that something crucial is missing, something we will have to confront when we talk about what it really means to reach the bottom at all. The door that won't open, engineering a way in. So if the bottom of the Pacific is mostly an absence in our data, a kind of negative space on our maps, then the next question quietly appears: how do we even knock on a door that far beneath the surface? Make yourself comfortable for a moment and follow me into a different way of seeing the deep, not as an open plain of water, but as a sealed room. We often picture the ocean as something you simply dive into, as if you could just keep swimming downward until you arrived. But in the Hadal Zone, under more than 1,000 atmospheres of pressure, the water itself becomes the wall. Imagine a room whose walls are made of cold, crushing liquid, pressing equally from every side. To enter that place, we don't just need a strong shell around us. We need a way to open and close hatches, to move joints and hinges, to route power and information through that invisible heavy barrier without letting it in. Now, picture what happens when you try to build a door in that wall. Every seal, every connector, every tiny ring of rubber or metal has to move under pressures that would flatten a building on land. Materials that flex easily at the surface can stiffen, creep, or deform, so a valve that turns smoothly in the lab might seize up in the deep, or a cable that seems solid might slowly compress until its insulation cracks. It's not just about being strong. It's about being strong while still able to move. This is where the problem becomes strangely intimate. A hatch must open wide enough for a sample arm, yet close so perfectly that not a drop can cross. A camera housing needs a window that can bow inward without shattering. Even a simple electrical plug, passing power through the hull, becomes a tiny battlefield between the inside world of air and the outside world of water and pressure. One microscopic flaw, one unseen scratch, and the ocean wins in an instant. If we add people to this picture, the stakes change again. Life support systems for a crewed dive have to work flawlessly in a place where any failure is instantly fatal, leaving no time for repairs, no second chances. Oxygen levels, carbon dioxide removal, temperature, humidity, all must stay within narrow limits inside a metal sphere that the deep is constantly trying to crush. For a few hours, that sphere is an entire world, as complete and self-contained as a tiny moving planet. And surrounding that fragile world is a nervous system of electronics and control systems that must keep thinking clearly while the pressure quietly alters the behavior of components, squeezes housings, and slows communication with the surface to a distant, muffled conversation. Signals travel through thick water, through armored cables that themselves can fail. A command might take long seconds to arrive, by which time the situation has already changed. Here is the pattern interrupt. We tend to focus on the heroic hull, the strong outer shell, as if once that barrier holds, we have won. But in reality, every moving part, every cable and hinge, every seal and connector is another place where the deep can slip in. Another opportunity for that cold, patient water to find a path and end the mission in milliseconds. The door to the deepest Pacific is not just hard to open. It may be that in any practical sense, it never fully opens at all. A gentle return to the mystery. Why this bottom stays hidden. So let's pause here right at that half-open door and let the noise of machinery fall away for a moment. Make yourself comfortable wherever you are, and let the idea settle in that there is a place on our own Earth that keeps itself hidden, not with walls or locks, but with sheer, unrelenting depth. We've talked about that depth as a kind of invisible weight, a column of cold water pressing down with more than 1,000 times the pressure at the surface, enough that even the strongest metals must be shaped into careful curves just to survive. We've traced how every seal, every window, every cable becomes a question mark when you sink into that world beneath the waves. And still, even when we win against the pressure for a few hours, we only ever win a tiny, fragile victory. Follow me, just in your mind, back down into that darkness. We often picture the bottom of the Pacific as a flat, still floor of mud, a quiet, simple destination waiting for a flag or a footprint. But now, picture what happens instead. The seafloor groaning and shifting, sediments sliding in slow underwater avalanches, tectonic plates grinding past each other over years and centuries, quietly rearranging which point is truly deepest. The bottom is not a single place. It is a moving target. Our submersibles, for all their elegance, are like visiting candles in a vast night. They dip down along a narrow path, see a slope here, a rock there, a small patch of life clinging to the sediment, and then they must rise again before the deep reminds them who is really in control. Sonar and satellites help us sketch the outlines from far above, but their view is coarse, smoothed out, more suggestion than portrait. We are trying to understand a mountain range by glimpsing only the faintest shadow. As you listen, notice what your own body is doing. Has your breathing slowed a little, as if matching the long-held silence of that trench? Is there, somewhere behind your eyes, a mental image of a narrow, dark cut in the ocean, a cold place where no sunlight has ever reached, where our machines look impossibly small? That quiet picture you're holding is, in some ways, closer to the truth than any map we have. Because the real question is no longer just, can we touch the bottom once, with one brave dive and one careful landing? It becomes, can we ever truly know it? Trace its contours, map every fold and fracture. Move through it as freely and routinely as we cross the surface world of ships and planes and cities. Or will it remain, by its nature, a mostly imagined landscape, stitched together from scattered tracks and fleeting visits? In the next part of our journey, we're going to turn from rock and pressure to something even more delicate. Beneath that crushing water, life has found a way to exist in the dark, in fragile ecosystems that may not survive too much attention from us. If the physics of the deep make intrusion hard, the living world down there may be the reason we shouldn't force it, even if someday we could. Life in the crushing dark, the fragile biology of the Hadal Zone. So now we leave rock and metal behind for a moment, and we turn our eyes to something softer, quieter, and far more fragile. Make yourself comfortable as we sink, in our minds, through layer after layer of cold Pacific water, until the last traces of sunlight vanish and only the slow fall of marine snow is left to mark the passage of years. Down here, in the deepest trenches of the Pacific, the world becomes almost unrecognizable. The temperature hovers just above freezing, a constant numbing chill that seeps into every cell. The darkness is absolute, not just night but the absence of any dawn. And above, 11 kilometers of water pressed down with a weight so immense that every square centimeter of skin, shell, or membrane must be shaped by pressure itself. Now, picture what happens to life in such a place. We often picture the deep sea as empty, but the Hadal Zone is not a void. It is a narrow ribbon of habitat draped along the trench walls and floors, where strange creatures move with unhurried grace. There are ghostly snailfish, their bodies soft and gelatinous, built not for speed but for survival under 1,000 atmospheres. There are amphipods, shrimp-like scavengers with transparent armor, and delicate sea cucumbers that sift the fine sediment, each grain a tiny archive of what has drifted down from the surface world far above. Beneath even these visible forms, microbial communities cling to particles and rocks, drawing energy from faint chemical gradients instead of sunlight. They live slowly, in a low-energy economy where every molecule counts, where a disturbance that would be trivial in shallow water can echo for a long time in the deep. Follow me in your imagination as we lower a bright, humming machine into that stillness. What does it feel like from their side? The truth is that many of these organisms are exquisitely sensitive to change. A sudden blaze of white light can startle or repel them. The low rumble of thrusters can send animals fleeing. A single careless burst of movement can kick up clouds of sediment that smother filter feeders or bury fragile tracks and burrows, not because the deep is weak, but because it has evolved for constancy, for darkness, for quiet. Even when we try to study these creatures gently, the simple act of bringing them toward our own world can destroy them. Bodies that are perfectly stable under crushing pressure can rupture, deform, or simply fail as that pressure falls away. Proteins that fold correctly in the Hadal cold and weight may unravel nearer the surface. Gases in tiny cavities expand, turning carefully collected specimens into something very different from what they were. To keep them alive, we need special containers that hold deep ocean pressure all the way up. And even then, many do not survive the journey. So true exploration here would have to be almost invisible. Dim red lights instead of harsh beams, quiet gliding instead of roaring propellers, instruments that watch and listen for years without stirring up the seafloor. Yet the machines we know how to build for such depths are thick-shelled, heavy and intrusive, designed first to endure the environment, and only second to blend into it. There is a tension here. The more robust we make our tools, the more they risk overwhelming the very life we hope to observe. And that leaves us with an uneasy question. If the only way to really see this hidden world is to change it, even a little, how far should we actually go? In the next part of our journey, we're going to step back from biology and look again at our own designs, and at why the very solutions that keep us alive in the deep may also be the reason we never truly belong there. The chemistry of an alien sea, strange fluids and hidden reactions. So if life itself forces us to tread lightly, there is another layer that asks for even more humility. The water, not the gentle blue we see from the surface, but the strange, compressed, reactive sea that waits far beneath, where the Pacific trenches fall into the dark. This is where the ocean stops behaving like the familiar world we grew up with and starts to feel quietly alien. Make yourself comfortable for a moment and imagine sinking past the sunlit waves, past the cold mid-depths where whales roam, down into water that has been isolated from the atmosphere for hundreds, sometimes thousands of years. Down here, oxygen can be scarce, stripped away by slow chemical reactions and by microbes that have been patiently breathing it in the dark. In its place, the water may hold high concentrations of dissolved minerals, metals, and carbon compounds, all stirred and seasoned by invisible exchanges with the rocks of the Earth's crust. Now, picture what happens when that crust begins to leak. Along parts of the trench floor, fluids seep up from beneath the sediments, carrying methane, hydrogen, and other reactive chemicals that would quickly vanish near the surface. Each seep becomes a tiny oasis, a cold spring in a cold place, where specialized microbes gather to feed on chemical gradients instead of sunlight. We often picture the deep as empty, but here and there, the chemistry itself builds small, hidden cities of life. Under pressures more than 1,000 times what we feel at sea level, even water is different. Its molecules are squeezed closer together, and that changes almost everything. How much gas it can hold, how fast reactions proceed, how minerals dissolve or crystallize. Metals that seem stable in a laboratory on land may corrode in unexpected ways. Plastics can slowly absorb water and swell. Lubricants thicken or separate. The very rules that engineers rely on at the surface begin to bend in the deep. This is where the dream of simply parking our instruments on the bottom starts to unravel. Long-term sensors and robotic landers must endure not just crushing pressure, but years of quiet attack, corrosion from mineral-rich fluids, biofouling as thin films of microbes and their byproducts coat every exposed surface, and slow chemical reactions that creep into seals, cables, and batteries. We're going to design them to last, of course, but how do you future-proof hardware for a chemistry we barely understand? Because here is the pattern interrupt. The bottom is not just far away, it is chemically foreign. It is a place where our steels, our ceramics, our electronics, all born in air and ice and sunlight, behave in unfamiliar ways. In the next part of our journey, we'll turn back to the machines themselves and ask what it really means to build technology for a world that quietly rewrites the rules of matter. A world we know better, learning from the Antarctic deep. So, if the bottom of the Pacific quietly rewrites the rules of matter, where on earth have we seen something like that before? To answer that, make yourself comfortable for a moment and follow me far from warm water and waves to a different kind of abyss, sealed not by crushing columns of sea, but by ice. Beneath the East Antarctic ice sheet, under nearly 4 kilometers of frozen weight, lies Lake Vostok, a world within a world. We often picture Antarctica as a flat white emptiness, a simple sheet of cold pressed against rock. But that's not what a glacier is. Under the smooth surface there are mountains, valleys, and in places like Vostok, liquid water held in darkness by pressure and geothermal heat. A lake larger than some of Earth's great surface lakes, yet completely hidden from the sky. Lake Vostok has been cut off from open air and sunlight for perhaps 15 million years. Its waters sealed beneath ice older than our species, older than many of the landscapes we know. In that time, sediments have settled on its floor. Tiny minerals and possible traces of life have accumulated in its depths, and the overlying glacier has flowed and thickened and thinned, while the lake itself remained in almost perfect isolation. Imagine a body of water that has listened only to the slow creak of ice and the faint hiss of the Earth's interior for all that time. When scientists finally decided to drill down, they moved with extreme caution. They worried that a single careless drop of modern fluid, a single cluster of surface microbes, could spill into this ancient place and overwrite whatever story it was telling. So they designed elaborate systems to keep the boreholes sealed, to use special drilling liquids, to stop just above the lake and let the water rise and refreeze, creating a kind of natural sterile plug. It was slow, expensive, and incredibly delicate work, carried out in one of the coldest places on Earth. Now, picture what happens when we turn our thoughts back to the Pacific trenches. The Haddle depths are not locked under ice, but they are still sealed in their own way, wrapped in darkness, in immense pressure, in chemistry that rarely mixes with the surface. Like Lake Vostok, they are extreme environments where our presence, our heat, our metals and plastics risk changing the very conditions we hope to observe. Just as radar and satellite data revealed that Antarctica is laced with hundreds of subglacial lakes and channels, many still untouched, the Pacific trenches almost certainly hold a patchwork of microhabitats we have barely glimpsed. Steep canyon walls with different minerals, pockets of warmer fluid, soft sediments where strange microbes sift through chemical energy instead of sunlight. We infer them from scattered samples, from subtle shifts in water chemistry, from the way life adapts wherever it can. But we haven't seen most of them directly. So when we talk about reaching the bottom, we're going to have to admit that there is no single bottom to claim, no final flag to plant, only a mosaic of hidden places, each as carefully guarded as Lake Vostok. And as we think about sending stronger machines into that deep Pacific night, we carry this Antarctic lesson with us. Every door we force open risks closing a more ancient one forever. In the next part of our journey, we'll ask what it would mean to build technology that can enter such worlds without erasing them as it arrives, mapping an ever-changing abyss, the limits of our deep maps. To build technology that can enter such worlds without erasing them, we first have to know where those worlds actually are. That sounds simple, but in the deep Pacific, even the act of drawing a map becomes a kind of quiet impossibility. We often picture the ocean floor as a crisp, shaded relief map in a textbook, every trench and ridge neatly outlined, every deepest point labeled like a mountain summit. Make yourself comfortable for a moment, and imagine instead what our instruments really see: a ship moving slowly across a restless sea, sending out fans of sound that sink through cold black water, bounce off rock and sediment far beneath, and return as faint echoes that computers must turn into shape. That's what our modern multi-beam sonar is, a way of listening for a world we can never touch directly. In the last few years, expeditions like the 5 Deep Survey have transformed that listening. Where we once had rough depth estimates spaced tens of kilometers apart, we're going to sweep narrow corridors with sound, building detailed ribbons of the trenches at resolutions that would have seemed impossible only a few decades ago. Follow me to the Challenger Deep, for example, where these new maps revealed that the spot we used to call the deepest place on Earth was, in fact, a little off to the side. Not wrong in a dramatic way, but wrong by tens of meters. A small number on the surface, yet in that Hadal world, under more than 1,000 atmospheres of pressure, it is enough to move the crown from one hidden depression to another. Now, picture what happens when we realize that several supposed deepest points across the Pacific were shifted like this, each one quietly dethroned by a more careful survey. It tells us that for years we were navigating with blurred outlines, mistaking a rough sketch for a finished portrait. And even now, after all that careful work, most of the deep Pacific is still known only at a coarse scale, like looking at a glacier from orbit and guessing at the crevasses beneath. Between the narrow sonar tracks, there are vast stretches where any small pit, any steep-walled crack only a few hundred meters across, could be the true deepest place, hiding in the unmapped gaps. Our maps feel solid, but they are stitched from assumptions. Then the seafloor itself refuses to stay still. Sediment slumps down trench walls. Tectonic plates grind and bend. Earthquakes jolt entire slopes into motion. Over years and decades, a few meters can be lost here, a few gained there, as if the bottom were breathing very slowly under the weight of the ocean. By the time we return with a new survey, the shape has already changed, just a little, and our beautiful previous map has become a record of a seafloor that no longer quite exists. So we find ourselves chasing a moving target with tools that always arrive slightly late. Not because we lack ambition, but because the Earth is quietly rewriting its own bathymetry in the dark. And this leads to a strange possibility, that we may never hold a perfectly precise final map of the Pacific's deepest trenches, only a series of shifting drafts, which raises a deeper question that will guide the rest of our journey. If the bottom will not stay put long enough to be captured, what does it really mean to say we've reached it at all? Remote eyes that blink. Why our robots often fail in the Hadal zone. So if the bottom itself keeps shifting away from us, we might be tempted to send something that doesn't mind the dark, or the waiting, or the years between visits. We often picture that as the easy part. Just build a robot, drop it in, and let it handle the cold and the pressure for us. But down in the Hadal zone, even our machines become strangely fragile. Follow me for a moment into that hidden world beneath the waves. Our main eyes and hands there are uncrewed free-falling landers, tethered remotely operated vehicles, and quiet autonomous underwater vehicles that roam without direct control. They sink through the deep like metal snowflakes, carrying cameras, lights, and delicate instruments, all wrapped in pressure housings that we hope will hold. We're going to lean on them because we cannot safely go ourselves, yet they are always one step from failure. Now, picture what happens when they cross that last invisible threshold where the pressure climbs past 1,000 atmospheres. Housings that seemed rigid in the lab begin to breathe in and out by fractions of a millimeter. Connectors that once fit perfectly are squeezed and twisted. Seals creep, and tiny gaps open where no gaps were meant to be. Batteries change their behavior in this cold, crushing place, giving less power or giving it in strange, unreliable ways. An electronic clock that keeps perfect time at the surface can drift down there, and a drifting clock can mean a missed signal or a lost vehicle. Over the years, landers have simply not come back. Some vanish into silence after a last brief transmission. Others return scarred, with bent frames, imploded glass spheres, or cameras that show only static. One expedition will celebrate a successful recovery, while the next, in the same trench, will find its instruments mute, their memory boards wiped, or their cables torn away. It is not always a dramatic catastrophe. Sometimes it is just a sensor that reads nonsense, and an entire dive becomes a blank page. Tethered ROVs face a different kind of difficulty. Their lifeline is a cable that must stretch from the ship at the surface all the way down into the trench, a single thread through 11 kilometers of moving water. As it grows longer, it grows heavier, sagging under its own weight, bowing in the currents, adding drag that fights every gentle movement of the vehicle. Steering becomes like trying to guide a kite made of metal and light, flown not in air but in a slow, dense river. And always there is the risk of that cable catching on a rock, wrapping around a spur of the seafloor, or simply snapping after years of use. When that happens, the ROV does not drift home. It becomes another quiet artifact on the bottom, another reminder that the Earth keeps what it wants. Even autonomous vehicles, free of tethers, must eventually rise, and sometimes they do not. So, make yourself comfortable with the strange idea that our remote eyes and hands at these depths do not watch steadily, but blink. They open for a few hours, then close again, leaving us with scattered, flickering glimpses of a world we can never quite hold in view, and nudging us toward a different question about what being there really means. The cost of chasing the deepest meter. Those blinking glimpses are precious, but they come at a cost that is almost as crushing as the pressure itself. Before we talk about new machines or clever designs, we have to slow our thoughts and look at something more mundane, and somehow even more immovable: distance, money, and the quiet politics of the deep. Follow me for a moment away from the trench floor and back up to the surface. The deepest cuts in the Pacific are not just deep, they are remote in a way that's hard to feel from a map. To reach the Mariana Trench, a ship may travel days across open ocean, threading narrow weather windows, timing its approach between storms and swells that can toss even large vessels around like toys. Every person on board is a specialist, every crane and winch and cable tuned to handle fragile, priceless submersibles that must descend through 11 kilometers of cold, black water and return again. We often picture exploration as a matter of courage, of just deciding to go, but each of those descents costs millions of dollars in ship time, fuel, equipment, and highly trained crews. Oceanographic institutes must choose. Do they spend that money on satellites, on coastal sensors, on climate records that affect millions of people, or on a single dive into a hidden valley of the seafloor that may last only a few hours? When research budgets are already thin, the deepest meter of the Pacific competes quietly with hospital studies, weather prediction, even education. How many times can we justify repeating the same journey just to move our lights a few meters to one side? Now, picture what happens when we ask not just for one heroic expedition, but for routine, detailed surveys, the kind that would slowly trace every fold and fracture of the Hadal world. Around the entire Earth, only a tiny handful of ships and submersibles can survive those pressures. Some are experimental, some are privately owned, some are booked years in advance. They become bottlenecks, like a single narrow tunnel through a glacier of demand. Dozens of projects, only a few vehicles, and long lines of patient proposals waiting for a chance at a single dive. Beneath all this lies another, quieter layer. Who does the trench belong to? Many of the deepest Pacific basins sit in international waters, beyond any one nation's borders, where treaties and committees decide what can be done, what must be shared, and who pays. If one country funds a high-resolution map of a deep valley, does it own the data, the minerals, the microbes? Or must they be open to all, even to those who might use them for extraction rather than understanding? These questions slow decisions, and when projects move slowly in a changing world, they often fade. So even if our technology grows lighter and stronger, even if our maps from above grow sharper, the combination of cost, distance, limited vessels, and competing interests forms its own kind of invisible ice over the deepest places. We're going to keep visiting, but not like commuters returning every day, more like rare pilgrims, separated by years, arriving to find that the seafloor has shifted again. And that leads us toward a final unsettling thought. What if the bottom is not just hard to reach, but changing faster than our scattered visits can ever follow? Imagining future machines, melt drills, swarms, and soft robots. So if the bottom keeps slipping away from us, what do we do next? We don't give up. Instead, we start to imagine stranger, quieter machines, tools that try to meet this deep world on its own terms, rather than forcing it to meet ours. We often picture deep-sea craft as armored bells, wrapped in thick metal holding out the water with sheer strength. But follow me for a moment into a different approach, where instead of fighting the pressure, we let it in. Engineers are already building instruments whose electronics are tolerant of crushing loads, tucked inside housings filled with oil so the pressure inside and outside stays almost the same, removing the need for those heavy, rigid shells. The machine becomes less like a submarine and more like a nervous system drifting inside a protective fluid. From there, the ideas grow smaller and more numerous. Imagine not one heroic vehicle, but a swarm of tiny robots, each no bigger than a fist, each carrying just a simple sensor. Or two, individually, they would be almost disposable. Together, they could spread out across a trench, tasting the chemistry of the water, listening for distant landslides, feeling the slow rain of sediment that has been falling for thousands of years. If one fails, the others go on, like a school of fish adjusting when a few vanish into the dark. Now, picture what happens when we stop insisting our machines be rigid at all. In the cold, black water beneath the Pacific, real creatures thrive without steel hulls. Soft robots, inspired by snailfish and gelatinous invertebrates, could use flexible bodies and fluid-filled muscles to move where hard shells would crack. They might squeeze into narrow gullies, ride gentle currents along the seafloor, and press sensor-studded skins against the mud, feeling the faintest tremor of shifting earth under unimaginable pressure. Around them, we're going to need patience. Long-duration landers, lowered once and then left alone, could settle into the trench floor and simply wait. For months, or even for years, they might watch for the rare flash of bioluminescence, listen for the deep rumble of a distant quake, or record the slow tilt of the seafloor as tectonic plates grind past each other. They would be like small observatories on an alien planet, quiet, persistent, almost forgotten at the surface. Make yourself comfortable with these possibilities, because they sound like solutions, and in some ways they are, yet they never quite escape the same old limits. Pressure still tries to seep into every seal. Remoteness still means days of travel and minutes-long communication delays. Cost still keeps the fleet small, and the target, that hidden, shifting bottom, still moves under our feet, erasing our careful maps faster than we can redraw them. So we stand on the deck of a ship, looking down into a cold, restless place we can touch only with these fragile extensions of ourselves. And a quiet question appears. What happens if even our most advanced swarms and soft machines are already out of date by the time they arrive? When the bottom runs away, a conceptual impossibility, by the time that question reaches us, the seafloor has already moved on. We often picture the bottom of the Pacific as a single, clear destination, a pin on a map, a final coordinate we can write down and conquer. But beneath that calm idea lies a restless world of folds and fractures, where the deepest point is more like a narrow, shifting crease than a solid, patiently waiting floor. Make yourself comfortable for a moment, and imagine that crease not as a line, but as something breathing, sagging, and lifting over years and centuries. Now, picture what happens as two vast plates of the Earth's crust grind past and under one another, dragging whole slabs of seafloor down while layers of soft sediment pour in like underwater snow. A landslide far away can send a slow avalanche of mud into the trench, filling one tiny depression while another opens a few hundred meters along. The cold water above presses down with unimaginable force, yet the rock and sediment beneath are still flowing, still adjusting, still changing shape. So when we say, "This is the deepest point," we are really saying, "This is the deepest point according to the last time we looked, with the tools we had, at the scale we could see." By the time we identify, map and plan a mission to that supposed deepest spot, the exact depth and outline of that crease may already be different. The bottom, in a very quiet way, has run away. Follow me into that thought a little further. Even if we could ignore the cold, the darkness, the pressure, and place an expedition submersible instantaneously on the coordinates of the deepest known pixel on our map, would we truly be at the bottom? Or might there be, just beyond the edge of our sonar footprint, a slightly deeper hollow, a sharper kink in the trench wall, a pocket we simply have not resolved yet? Our instruments blur the seafloor into patches and contours. The real landscape is sharper, more intricate, full of tiny basins and cracks that hide in those blurs. Here is the pattern interrupt. Perhaps the impossibility is not mainly about depth at all. Perhaps it is about definition. To reach the bottom sounds like a singular final achievement, the way we talk about summiting a mountain or standing at a pole. But the Earth's crust under the Pacific does not behave like a peak or a point on a compass. It sags, it fractures, it accumulates, it erodes, all at once. In that sense, the bottom is less a place and more a moving boundary, a horizon between rock and water that we can approach, measure, and touch in a few scattered locations, but never fully fix and claim. We're going to keep improving our maps, sending better machines, and learning more about this hidden cold frontier, yet each new measurement will quietly redraw the line we thought we had reached. And as we look ahead, we start to realize that the real story is not whether we ever stand on the single deepest grain of sediment, but how we choose to explore a floor that is always gently slipping out of our grasp. A quiet parallel, the deep Pacific and distant ocean worlds. And as that seafloor keeps slipping away from us, almost politely refusing to stay still, another thought begins to surface. Maybe this restless hidden floor of the Pacific is not alone. Maybe it has distant cousins scattered through the cold outer reaches of our solar system. Follow me for a moment, and make yourself comfortable. We often picture oceans as blue surfaces under sunlight, waves and coastlines and familiar shorelines. But imagine an ocean that never sees the sky at all. On Jupiter's moon Europa and Saturn's moon Enceladus, there are entire seas sealed beneath shells of ice tens of kilometers thick, locked away in permanent night, their water pressed and stirred by the slow pull of gravity instead of winds. Astrobiologists, the scientists who wonder about life beyond Earth, keep turning their attention back to our own deep trenches when they think about those distant places. The hydrothermal vents scattered along the Pacific's Hadal slopes, where hot, mineral-rich water seeps out of the crust into near-freezing darkness, become quiet stand-ins for vents that might exist under Europa's ice, or in Enceladus's buried ocean. Now picture what happens when we lower an instrument into one of these vents. We are not just studying a strange corner of our own world, we are rehearsing for an encounter with an alien sea. Both settings share the same simple, unsettling conditions: no sunlight, immense pressure, a complete separation from the gentle energy that falls on Earth's surface every day. Instead of green plants and photosynthesis, life here must rely on chemistry itself, on microbes that take the energy stored in hydrogen, methane or sulfur, and build entire ecosystems in the dark. If such communities can bloom around a Pacific vent, could something similar be growing, very slowly, under an icy crust hundreds of millions of kilometers away? And yet, just as the Pacific refuses to yield its deepest grain of sediment, those other oceans remain even more remote. We're going to send orbiters, and maybe Xanders, to Europa and Enceladus, but drilling through kilometers of ice to walk on their seafloors is far beyond us. Not because we lack imagination, but because ice flows, fractures, and closes behind anything we push through it, the way a glacier on Earth slowly heals its own wounds over years. In that sense, the Hadal Zone becomes a quiet bridge. It lets us touch, just barely, the kind of worlds that may exist throughout the universe, without ever fully owning them. We lower cameras and sensors into a place that feels part Earth, part alien planet, and the darkness that answers back hints at countless other oceans we may never enter. And as we listen to that echo, we start to ask, if even this nearby deep remains mostly out of reach, what does that mean for the way we explore the rest of our own planet's hidden water, sealed under ice and rock much closer to home? Ethics in the abyss. Should we even try to go all the way down? So, as we listen to that echo from the trench, from a world that feels part Earth and part something else entirely, another question rises up very quietly beneath all the talk of technology and courage. Should we even be trying to go all the way down? Before we design stronger hulls and brighter lights, we have to slow our thoughts and ask what it really means to press ourselves into a place that has been sealed away in cold darkness for millions of years. We often picture exploration as an unquestioned good, a kind of gentle lantern we carry into every hidden corner of the planet. But the deepest Pacific trenches are not empty rooms waiting to be lit. They are more like ancient libraries, written in chemistry and pressure instead of paper, where each strange creature and fragile microbial film has been copying itself in peace for longer than our species has existed. When we lower a machine from the surface into that abyss, we are not just visiting, we are changing the story. Imagine a submersible descending through water that has never seen a fragment of plastic, never tasted a trace of our fuels or our fertilizers. Now, picture what happens if even a single flake of paint, a thread from a synthetic rope, or a cluster of surface microbes rides along on the hull and settles into the sediment. In a world where life has evolved to match one narrow band of temperature and pressure, that tiny intrusion can be as disruptive as a storm. The abyss feels distant, but it is not immune. Scientists already worry about this, with every probe they send into sealed Antarctic lakes beneath the ice, sterilizing instruments until they are cleaner than an operating room, and still wondering if it is enough. In the Hadal trenches of the Pacific, where every recovery is difficult and every dive is precious, that same care becomes even harder to maintain. The more often we go, the more doors we open for our own chemistry to drift down and settle where it does not belong. And just beyond those careful expeditions, another pressure is building. Deep-sea mining companies are studying the very same ocean floor, mapping metal-rich nodules and mineral-laden slopes, imagining vast machines scraping along the bottom in the dark. We're going to hear more about this in the years ahead as demand for rare elements grows. But how do you weigh a short burst of industrial gain against ecosystems we barely understand? Against trenches that may shift and collapse under the disturbance, sending clouds of sediment through habitats that have never known such violence? There is a quiet argument, growing stronger, that some parts of the deep should remain almost untouched, not because they are useless, but because their value lies in their mystery. They can be living laboratories that continue without our interference, control groups on a changing Earth, places where life writes its own experiments in the language of time and pressure. To leave them mostly alone is not to give up on knowledge. It is to admit that not all knowledge must come from direct contact. In that sense, the very impossibility of fully reaching the bottom of the Pacific may be a kind of unplanned protection, a soft boundary that our materials, our bodies, and our budgets cannot quite cross. The ocean itself is saying only so far, drawing a line of pressure and darkness that blunts our most intrusive impulses. But if we accept that line in one place, what does it mean for the other frontiers we're already planning to touch next, both in the sea and far beyond it? A soft recap, gathering the threads of pressure, motion, and mystery. So now, as that line of pressure and darkness settles in your mind, make yourself comfortable again, and let's quietly gather the pieces of where we've been. We're going to trace them slowly, so you can feel how they fit together into something larger than any single trench or single dive. We often picture the bottom of the Pacific as a clean, sharp point, a pinprick in a map, waiting for a flag and a photograph. But beneath the surface there is only water and rock and motion, stacked in ways our bodies were never built to meet. At the very deepest places, the pressure rises to more than 1,000 times what you feel at sea level. A cold, invisible weight that would crush almost any metal that isn't shaped and engineered with exquisite care. Follow me back through that idea of pressure and what it really asks of us. To keep a small human space intact down there, we have to surround it with thick hulls, flawless seals, life support systems that cannot fail, and control electronics that still behave in a world where every cable, every bolt, every tiny gap is being squeezed. Not because we lack imagination, but because the physics of our planet set a hard ceiling on what materials can survive without becoming so heavy and clumsy that they can barely move. Now, picture what happens even if we solve that, at least for a moment. The seafloor itself is not a flat, patient stage. It is a restless boundary where tectonic plates dive, sediments slump, and landslides reshape the landscape in silence and darkness. The deepest point is not a fixed address. It migrates by meters, then by tens of meters, over years and centuries, changing faster than we can map it in detail. How do you reach the bottom of something that keeps quietly rearranging its own floor? And all the while, in that hidden world, there are fragile forms of life, adapted to the cold, the chemistry, and the immense pressure, creatures that may not survive the wash of lights, noise, and stirred-up sediment that follows our machines. So far, we have only brushed against a few tiny patches of the Hadal Zone, with a handful of dives compared to thousands of trips into low Earth orbit, each visit brief, careful, and incredibly expensive, like tapping on a distant window and then drifting away again. So when we say we may never truly reach the bottom of the Pacific, we're not saying we learn nothing. We're saying that our knowledge will always be partial, stitched together from echoing sonar, remote instruments, and those rare descents that end almost as soon as they begin. Not a single perfect photograph of a final place, but a mosaic of glimpses. If you notice your own idea of the bottom shifting, that's part of the journey. It's no longer a dot on a chart, but a living, moving, layered boundary between rock and water, between what we can touch and what we can only infer. What does it mean to live on a planet where some places remain, by their very nature, unreachable? In a moment, we're going to sit with that question more directly and explore what it does to us, not just as scientists or explorers, but as humans who have to learn to share the Earth with mysteries we cannot quite resolve. Living with unreachable places, why some depths stay dark. So, make yourself comfortable again and slow your thoughts just a little, because we're going to stay with that feeling of not quite being able to get there, of standing at the edge of something the Earth has quietly decided to keep for itself. We often picture our history as a long, steady brightening of the map, a world where blank spaces are slowly colored in, where mountains get climbed, polar ice gets crossed, and every unknown bay eventually receives a name, a flag, a date written neatly in some logbook. For centuries, that was the story we told about ourselves. Given enough time and enough tools, there is no corner of the surface we cannot reach. But the deepest Pacific trenches do something different to that story. They sit far beneath the waves like folds in a dark, heavy curtain, places where the pressure climbs to more than 1,000 times what we feel at the surface. Places so remote that only a handful of people have ever passed through their cold water in person. Not once a week, not once a year, but a few rare descents scattered across decades, each one more like a brief visit to another world than a step toward routine travel. Imagine how that contrasts with the rest of our exploring instincts. We build highways to high passes, cable cars to snowy peaks, tourist flights over the poles. Yet there is no ordinary route down into the Hadal trenches. No simple way to look around, turn your head, and say, "Ah, so this is the bottom of the Pacific." Instead, we have grainy sonar maps, cautious dives, and instruments that touch down for a few hours and then rise back up through kilometers of black water. Now picture what happens inside us when we realize that this pattern might never really change. There is frustration, of course, a quiet sense that with better hulls, stronger metals, more money, we ought to be able to sit comfortably on that seafloor as easily as we sit in an airplane seat. There is awe, too, in knowing that the Earth still holds a cold, hidden architecture of trenches and slopes, and sliding sediments that no human eye has traced in fine detail. And perhaps, if we listen closely, there is a thin thread of relief. Because what if not everything has to yield? What if the exact contour of the deepest crease in the Pacific can remain a question mark on our mental map without making the world feel smaller or less understood? We can still know how plates dive, how sediments fall, how life adapts to crushing pressure without numbering every stone. So, follow me to a gentle compromise, a planet where some places will always be more imagined than experienced, more inferred than walked upon. In the next part, we'll see how that acceptance doesn't end exploration at all, but reshapes what it means to explore a deep, restless Earth we can never fully touch. You, here, and the trench, they're bridging vast distances in the mind. So follow me not with equipment or maps this time, but with something much lighter, and in some ways, much stronger. Your attention. Right now, wherever you are, make yourself comfortable. Feel the softness of the pillow under your head, or the familiar give of the chair beneath you, the gentle way it receives your weight and spreads it out. The air around you is mild, the pressure on your skin so ordinary that you almost never notice it. It's a small, safe corner of the world, lit just enough for you to see. Now picture what happens if we drop a line straight down from your room, through the ceiling, through the roof, through the night air. It passes the clouds, the cruising height of plains, the high, thin cold where the sky darkens. It keeps going, through the last traces of light, until it touches the surface of the Pacific and slips quietly through. From there, it falls through thousands of meters of water into a column that grows heavier and heavier, the pressure building, until it would crumple almost anything we could build. At the very end of that line, far beneath the waves, is a hard, cold plain of sediments, grains of rock, and shells that have been drifting down for years, for centuries, for whole slices of Earth's history. Down there is no soft pillow, no chair, no warm lamp, just the slow rain of particles settling into a darkness so complete it barely feels like part of the same planet. Imagine in that darkness a single amphipod, translucent and small, or a pale snailfish easing its way a few centimeters above the seafloor. It moves without hurry, feeling tiny changes in the water, tasting faint traces of food, entirely unaware that far above it, continents shift, cities glow, and someone is listening to a quiet voice talk about a hidden trench. To that animal, the world is a narrow band of cold water and silt. The rest of Earth might as well not exist. And yet, in this moment, it does exist for you. Your mind has stretched from your bed or your chair to that distant crushing place, and for a few breaths, your attention is the only bridge between them. No cable, no submersible hull, no reinforced window could connect your room to that depth as easily as this simple act of imagining. We often picture exploration as motion. Ships leaving harbor, rockets rising through ice-blue sky, people stepping onto new ground. But tonight, we're going to let exploration be stillness. Without leaving where you are, without even lifting your head, you have traveled farther in mind than most of us will ever travel in body, crossing not just distance, but pressure, darkness, and an almost total absence of human presence. There is a quiet power in that. When we accept that we may never truly stand on the bottom of the Pacific, that our machines may always be brief visitors in a restless, shifting trench, imagination stops being a consolation prize and becomes its own kind of reaching. This may be the closest we ever come to truly being there, feeling, however faintly, the weight of all that water, the slow drift of life, the deep time stored in those sediments. But if the only bridge is in our minds, what does that mean for the way we study a place we can barely touch at all? A last look upward, how the surface depends on the deep. To answer that, we have to turn around for a moment and look back up from the imagined floor of the trench toward the world we actually live in. We often picture the deep Pacific as a separate realm, a cold, sealed vault far beneath the everyday weather and waves. But the truth is quieter and stranger. It is already with us, shaping the air you breathe and the seasons that pass above your head. Make yourself comfortable and slow your thoughts for a moment, because we're going to follow a single thread of water as it sinks. At the poles, where the ocean brushes against ice and winter air, surface water cools, grows saltier, and becomes heavy enough to plunge downwards, beginning a journey that can last hundreds, even thousands of years. Now picture what happens as that dense water slides along the deep contours of the Pacific, guided by ridges and trenches, the way wind is guided by mountains on land. This deep circulation is not fast, and it is not dramatic, but it is one of the great hidden engines of Earth's climate. As those bottom currents creep along trench walls and spill into abyssal plains, they carry heat away from the surface, store it, and slowly release it elsewhere, helping to smooth the contrast between tropics and poles. Not in the space of a news cycle or a single storm, but over long, patient stretches of time that span generations. Without that slow conveyor beneath, our surface world would be harsher, more extreme, less forgiving. The trenches also act as archives. Every year, a faint snow of particles drifts down, dust from deserts, tiny shells from the upper ocean, fragments of volcanic ash, bits of plastic fibers and paint flakes from ships. Layer by layer, they settle into the deepest grooves of the Pacific, pressed under unimaginable pressure into thin bands of memory. Organic carbon from dead plankton is buried there too, locked away instead of returning immediately to the air as carbon dioxide. In their own quiet way, these deep basins help keep our atmosphere and our climate within the narrow range we find livable. And yet, the connection is not always gentle. Along many Pacific trenches, one plate of the Earth's crust is forced beneath another, in long subduction zones that can sit silently for years and then shift in minutes. When they do, the seafloor can lurch upward or downward by several meters, sending tsunamis racing across entire ocean basins. A wave that begins as a barely noticeable rise in the open Pacific can arrive hours later as a wall of water on a distant shore, reshaping coastlines and communities that have never seen the trench itself. So the deep Pacific is not a distant alien place we can safely ignore. It is woven into the same Earth system that gives us rain and wind, that stabilizes our coastlines, that lets cities and forests and glaciers endure from one century to the next. Even if we never set a human foot on that shifting floor, the trench is already participating in each calm day and each storm you experience at the surface. In that sense, the bottom we may never reach is already reaching us, quietly, through climate, through sediments, through the occasional violent shudder of the planet. And if the abyss is part of our everyday world, then the next question becomes inescapable. How do we study and protect a place that holds our future when we can barely touch its present? Softly re-asking the question, what does never really mean? So when we say we can barely touch its present, another quieter question appears in the dark with it. What do we really mean when we whisper that humans will never reach the bottom of the Pacific? Make yourself comfortable for a moment and slow your thoughts, because that single word can sound so final, so absolute, that it almost freezes our curiosity in place. We often picture never as a locked door, a hard wall in the deep, like some cosmic rule that no amount of clever engineering or patient effort could ever bend. But if we look back just a few hundred years, almost everything about our world would have seemed impossible to the people walking the Earth then. We've walked on the moon. We've sent machines past the edge of the planets. We've mapped the cold, hidden underside of ice sheets that no human eye had ever seen. The universe keeps surprising us. So when we use the word here, we're going to mean something softer, something more human. Not never in all of time, but never in the way we usually imagine it. Not a neat flag planted on a single point, not a brightly lit research station on the seafloor. Not routine, detailed, flexible access to every fold and fracture of the deepest trenches, the way airplanes now cross the sky. For the foreseeable future, that kind of relationship with the abyss is out of reach. Imagine the very bottom of the Pacific, not as a flat waiting surface, but as a restless, shifting landscape, where sediments slide, where tectonic plates grind, where the true deepest point can migrate by meters or more as the years pass. Even if we discover new materials that shrug off the pressure, even if we build submersibles that can sit there for days, the place itself will not sit still for us. The floor moves, the walls crumble, the targets drift away while we are still on our way down. Now, picture what happens when we try to scale that up from a single daring dive to something like permanent presence. Every hatch, every cable, every seal has to survive pressures that would crush a glacier of steel. Every life support system has to work in a world where rescue is, for all practical purposes, impossible. The bottom remains remote, fragile, and easily disturbed, and the more we try to tame it, the more our own weight and warmth begin to change it. In that sense, never is less a brick wall and more a horizon. As we walk toward it, it retreats. As technology advances, the line of the possible moves with us, yet there is always some last canyon unvisited, some last organism still hidden in the dark. There is always a little distance left between our instruments and the full truth of the place. So when you hear never in this story, let it rest in your mind as an invitation rather than a verdict. An invitation to wonder what might change and what might always stay just beyond our fingertips. Because the bottom of the Pacific is not only a destination, it is also a reminder that some parts of our world remain stubbornly wild, and that our task may be less to conquer them and to learn how to listen from far above, with care. And from that gentler understanding, we can turn to a different kind of question. If we accept those limits, how do we decide what kinds of journeys into the abyss are still worth making? If we could go freely, imagining an impossible expedition. So make yourself comfortable for a moment and slow your thoughts, because before we talk about what we can't do, we're going to allow ourselves to imagine what it would feel like if we could. Not in rough prototypes and fragile test dives, but in a calm, almost ordinary journey into the deepest cold water on Earth. Imagine a vessel that treats the Pacific Trench the way a sturdy car treats a quiet night road. We slip away from the surface, leaving the restless skin of waves behind, and the descent is smooth, unhurried, almost silent, the immense pressure outside rising from a few atmospheres to hundreds and then more than 1,000. Yet our hull does not groan, does not complain, does not even notice. We talk, we breathe, we pour a cup of tea, as if we were still in a small room on land. Now picture what happens when we arrive. The bottom is not a single point, but a long folded world of cliffs and small valleys, of trench walls that rise like frozen waves of rock and sediment, of soft plains where fine particles have been falling for years and years. We glide along those walls as casually as you might drive beside a line of dark trees, stopping wherever curiosity tugs at us, backing up, turning, hovering in place with no fear of being trapped. We often picture these depths as empty, but in this impossible expedition, we have lights so gentle and sensors so patient that the creatures here do not flee. We dim the beams to a faint blue and watch a translucent snailfish pulse slowly above the sediment, see tiny crustaceans drift like pale snow beneath us. Notice thin threads of life rooted in the seafloor where chemicals seep from the rocks. We can linger beside them, not for minutes, but for hours, adjusting our presence until we are almost part of the background. In this vision, the vessel is not just a visiting capsule. It is a small, moving habitat. We stay for weeks, even months, anchored in a sheltered depression at the trench floor, while teams of scientists rotate in and out like crew on a remote polar station. One group spends a night watching a slow landslide creep down a slope, grain by grain. Another maps a new fissure where the Earth's crust bends, measuring how the shape of the trench changes over time. Others sample rocks and the cold, mineral-rich fluids that seep from the seabed, building a long, continuous record of this hidden place. We would learn how storms at the surface send faint pulses all the way down, how the rain of organic particles thickens and thins with the seasons, how the deep currents reshape the trench walls over years in ways we can barely imagine now. It would feel less like a visit and more like moving into a neighborhood that has always been there, beneath us, waiting. But every part of this tranquil fantasy is, for now, beyond us. A hull that shrugs off that kind of pressure without becoming impossibly heavy, thrusters that can move freely in water that dense, life support systems that run for months without resupply, costs low enough that such journeys are routine rather than once-in-a-generation events. Each of these is not a small upgrade, but a major unsolved challenge. Not because we lack imagination, but because the Earth's own physics, quietly, relentlessly, pushes back. And yet, this is precisely what makes our brief, imperfect dives so precious. Each grainy video clip, each muddy sample hauled up from the deep, is like a short, vivid dream of a world we cannot truly inhabit. The question, then, is not just what we would do if we could live down there, but how we choose to use those rare moments when the abyss lets us in at all, and what we might risk or disturb the next time we try to knock on that door. Letting the abyss be, finding peace in partial knowledge. Those brief, imperfect dives leave us with something else as well. A question about how much we truly need to see. We live in a time when almost every corner of the surface of the Earth seems mapped, photographed, and available on demand. when we can zoom from a city street to a mountaintop in a few slow swipes of a finger. Information feels instant, total, always just one more search away. But the deep Pacific does not work like a search bar. It does not load faster if we tap harder. Down there, beneath kilometers of cold water and unimaginable pressure, is a place that refuses this constant demand for access, a part of our own world that stays fundamentally out of reach no matter how many screens we stare into. In a way, it quietly contradicts the story we often tell ourselves about progress, that if we just build enough machines, we will eventually know everything. Make yourself comfortable for a moment and slow your thoughts. Imagine a map of the oceans pinned to a wall, all those blues shaded and labeled, trenches marked with neat numbers. It looks complete. It looks finished. Yet we know that in the Hadal depths, the seafloor is shifting, sediments are sliding, and the very point we call the deepest can move between measurements. The line that says, "Here is the bottom," is in truth more of a guess than a boundary. There is a kind of peace in that, not the peace of having every question answered, but the quieter, older peace of accepting that some questions are allowed to remain open. We do not need to photograph every rock, weigh every grain of deep-sea mud, or trace every current that curls through that darkness. Some maps can stay incomplete and still guide us. Some silences do not need to be filled. Now, picture what happens when you notice your own curiosity here. You care about this unreachable place, this trench you will almost certainly never see with your own eyes. Your interest changes nothing in the abyss. No light flicks on, no fish turns its head, no pressure gauge twitches. Yet something in you shifts. A new shape appears in your inner world, a sense that beneath the familiar surface of things, there is always more, and that it is all right if that more stays hidden. Follow me just a little further, and then we'll let the water close. We're going to leave the Pacific floor exactly as it is, untouched by us, and let it remain mostly imagination tonight. It is enough for now that we have visited in thought, that we carry a quiet awareness of that deep, cold space. When you finally turn out the light, you might find that awareness drifting with you into sleep, like a distant trench, lying calmly beneath the waves of your dreams. A slow ascent, bringing you back from the deep Pacific. So now, as that distant trench settles back into the dark, we're going to turn very gently toward the surface again, as if our thoughts themselves were a small submersible beginning a slow, careful climb. Imagine the floor of the Pacific falling away beneath you, not because you are sinking, but because you are finally rising, pulled upward through a column of water so high it almost feels like years stacked on top of one another. At first, nothing changes. It is still black, still silent, still heavy with pressure and cold. Then, far off, there is the faintest suggestion of motion, a drifting cloud of pale sparks, and as we pass, we realize they are tiny creatures making their own light in a world that never sees the sun. We often picture the deep as empty, but here and there, a slow pulse of blue, a brief green shimmer, a thread of soft purple glow reminds us that even this hidden place is alive. Follow me through that water for a moment, and at the same time, notice the air resting quietly around your own body. Make yourself comfortable if you haven't already. Let your shoulders drop a little, as if some invisible weight has just been lifted. The way the ocean's weight eases, meter by meter, as we drift upward from the trench. Can you feel your breath now moving in and out, slower than it was when we first began this journey? Now, picture what happens as we keep rising. The flashes of bioluminescence thin out, the darkness becomes less absolute, and somewhere very far above, a hint of direction appears, a sense that there is a up again. In your room, that same gentle orientation is there too. The quiet outline of a ceiling, the familiar touch of fabric, the steady calm rhythm of your heartbeat, no longer squeezed by the thought of all that water pressing down. You might want to take one deeper breath, letting it fill not just your lungs but the space behind your ribs, then let it go, slowly, as if you were leaving a little of the trench behind with each exhale. Maybe you shift your shoulders, or your neck, or your hands, and feel the warmth of this place, compared to the imagined cold that waited miles beneath the Pacific. Not an icy, crushing world now, but a safe, small room on the surface of the Earth. If your attention wandered in and out, that's all right. Minds move like currents, not like straight lines. Somewhere inside, you still followed the arc from surface to abyss and back again, tracing the outline of a world we can barely touch, and yet can so easily imagine. As we approach the faint suggestion of surface light, let that calm stay with you, a little awestruck by the deep, and gently grounded in the simple fact that you are here, breathing, held by air instead of ocean. In a moment, we'll open our eyes a bit wider and look at what this unreachable depth can still teach us, even if we never truly stand on its shifting floor. Holding the deep in mind, a soft recap and farewell, so as our little submersible mind rises toward that faint suggestion of light, let's pause together in this in-between and let the whole journey settle. Make yourself comfortable again if you've shifted. We're going to gently gather the pieces of this deep, cold puzzle and hold them in our hands for a moment before we let them go. We often picture reaching the bottom of the Pacific as a single, triumphant moment, a flag, a footprint, a clear, flat surface waiting for us. But the reality we've been exploring is quieter and stranger. Down there, the pressure climbs to more than 1,000 times the air that rests on your skin right now, turning water itself into something heavy and unforgiving, asking our metals, our seals, even our ideas about safety to bend almost to their breaking point. It isn't just pressure, though it starts there. It's the way our strongest materials must become thick and heavy just to survive, the way every bolt and window grows clumsy under that weight, the way the ocean is never still, its trenches slowly folding and slipping, so that the deepest point is not a fixed place on Earth, but a moving target, reshaped over years and centuries by hidden landslides and grinding plates beneath the surface. Now picture what happens when we try to live there, even for a few hours. Life support systems strain, controls lag, a tiny leak becomes a quiet, absolute ending. The biology we're hoping to meet is fragile too. A single snailfish, pale and soft, hovering in the dark beside a narrow crease of sediment that is itself sliding grain by grain, always rearranging the floor we claim we want to stand on. We have touched it, in places. A few craft have rested briefly in the Challenger deep. Instruments have kissed the mud and risen again. Cameras have stared into that black water and brought back images of drifting particles and patient alien shapes. But the kind of routine, flexible, almost casual exploration we enjoy in shallower seas, the ability to wander, to return, to map and sample as if it were just another place on a map, remains far beyond us, held back by cost, by risk, and by the ocean's own slow motion. So we find ourselves in a world we can measure, but not truly inhabit, a depth we can visit, but not really claim. And maybe that's all right. As you slow your thoughts, you might feel a small comfort in knowing that on this Earth, which we have crossed with ships and satellites, there is still a region that stays mostly its own. Thank you for sharing this long, quiet descent, whether you watched every moment or drifted somewhere between waking and sleep. Your attention, your presence here in this hidden corner of the night, is what allows us to keep building these gentle journeys, to keep this calm little world alive beneath the noise of the surface. In a moment, we'll offer a soft invitation. Nothing urgent, nothing loud, just a way for you to help us return to places like this again. But before we talk about that, there's one more thing the unreachable bottom of the Pacific has to show us. Something that reaches all the way back up into your everyday life on land, keeping this gentle corner afloat. Soft CTA and good night, our everyday life on land is still connected to that unreachable floor in ways we rarely notice. But for now, we're going to let the science grow quiet and let the story fade into something softer, something you can fall asleep inside. If you're still with us, still awake enough to notice the sound of your own breathing, you can make yourself comfortable where you are, maybe adjust the pillow or the blanket, and just feel how far away that cold, dark place really is from the warm little world you've built around yourself tonight. Not everything has to be solved before you sleep. Not everything beneath the surface needs to be mapped. If you feel like it, and only if it doesn't disturb the calm you've found, you can tap like on this video, or subscribe, or leave a quiet comment telling us where in the world you're listening from. A city apartment with traffic humming outside, a farmhouse under winter ice, a dorm room, a ship at sea, wherever you are on this turning earth, your small signal reaches this small channel. Not because algorithms demand it, but because it helps us keep this gentle corner of the internet lit, just enough to see by. We often picture the internet as loud, restless, always refreshing, but here we're trying to do something slower, more like a deep current than a crashing wave. A place for contemplative journeys into unreachable trenches, hidden glaciers, and the dark spaces beneath our familiar maps. When you subscribe, or leave that soft trace of yourself in a comment, you're not just helping a video, you're helping us return to these distant edges of the world, again and again, with the same unhurried pace. If your eyes are heavy, you don't need to move at all. You can just let this video keep playing, or queue up another voyage into some other deep unseen place, and let the sound of it drift around you like water in a quiet bay. You don't have to follow every word. You don't have to remember every fact about pressure, or ice, or rock. You can let it all pass by above you, like slow clouds over a sleeping sea. And if you're already half gone, hovering in that space between waking and dreams, there is nothing more you need to do. No more buttons to press. No more choices to make. Just slow your thoughts. Let your jaw unclench. Let your hands grow heavy where they rest. We'll keep watch for a while longer. Before we go, imagine one last picture. Far below the waves, deeper than ships, deeper than light. The trench is still there. The water is still pressing down with unimaginable weight. The sediment is still settling in slow motion over years and years. Our attention doesn't reach it. Our machines mostly don't either. Yet now, as you drift towards sleep, that hidden fold in the Pacific exists faintly in your inner world, a quiet shape in the dark, unchanged by us, but gently remembered by you. Good night, from the surface to the deep.